Hello everyone, welcome back to my channel, and in a very short while we're going to be solving this particular question that you have seen before you. Now before you run into any problem, let me just quickly give you an insight into what you're going to be doing. And the first thing is that you might be looking at this particular question from two perspectives. You can look at it from the perspective of being an initial equation, and also you can also look at it from the perspective of a polynomial. So whichever way you look at it, you are actually correct, because once you see a question of this nature, there are certain initial laws that comes to your mind very quickly. Now let me just show you something before we go ahead. Now first thing, you might be thinking that this is a polynomial of degree 4. That is, it's very important that I cite this, because if that's your mindset at first, you might be looking out for 4 solutions. Eventually, we might not have up to 4 solutions, because this is not actually a polynomial of degree 4. By the time we simplify further, you'll be able to understand that this is actually not of degree 4. But just looking at it, you might see it as a polynomial of degree 4, hereby, um, hereby waiting for 4 solutions for x. But in this case, we are not going to be having 4 solutions. And along the line, you understand why. That's the first thing. And secondly, we know that generally, when we are dealing with indices, if you have x raised to the power of, let me say, a minus 2, 2, also s raised to the power of, let me say, 2a minus 2. The law of indices states that if the base, this x is what we refer to as the base, if the base on the left hand side is same as the base on the right hand side, indices states that you can actually equate the power. So in this case, it implies that a minus 2 equals to 2 minus 2. And also in the reverse, if the power is the same, indices also state that means that the base must be equal. So if I have something like this, if I have a raised to the power of 2y equals to b raised to the power of 2y. The law of indices states that a and b must be the same since they have the same power. That's a very valid law in indices. But where the problem lies is that if you look at that from this perspective, look at this equation from this perspective, that means that your x must be equal to x minus 1. But literally, if you decide to simplify just like that, apart from the fact that you will have just one solution, you might also run into trouble if you just see it from that perspective. So it means that if the power is the same, just like in this case, we have 4, and we have 4 on the right hand side and also on the left hand side. So it also tells us must be equals to x minus 1. But look at it this way, we simplify this, x plus x equals minus 1. Of course, this particular equation does not have a solution. But along the line, I will show you what you need to do so that you can arrive at a solution easily and safely. And let's dive into this quickly. Now, the first thing you do is we need to expand the expression on the right. We have x raised to the power 4 equals to x minus 1 raised to the power of 4. But the first thing we do is we need to expand the expression on the right. And there are 2 ways you can do that. We can use the Pascal's principle. We can also use the binomial expansion method. But both methods is just for you to get the coefficient of your terms. So whichever way, you still get the same answer. But in this lesson, I'm not interested in diving too deep into expansion of polynomial. But if you find it difficult to do, you can also leave me a comment in the comment section, and I'll be there to attend to your problem. Now let me go ahead with this. Let me take this off. So if I expand this using any of the methods I stated, so it implies that x raised to the power 4 equals to, when I expand, I have x raised to the power 4 plus 4, x raised to the power 3, open a bracket, minus 1 plus 6x squared, open a bracket, we have minus 1 raised to the power 2 plus 4x, open a bracket, 1 raised to the power 3, then the last thing will be minus 1 raised to the power of. Then if I go ahead, now you might be confused how I got all of these coefficients. Let me just throw a little light on Pascal triangle. This is triangle 1, 1, just a differential for those that have learned this for 2, 1, and 1, 3, 1, and 1, 4, 6, 4, 1. I can go ahead. The next one will be 1, 5, 10, 10, 5, and 1, and so on and so forth. But this is just by the way because I'm not teaching Pascal triangle in this lesson. Now, since we are expanding an expression that has power of 4, all I just need to do is just count. The first one is 0, which is 0, 1, 2, 3, 4. So we're interested in this particular level. So which means the first term we have coefficient of 1, the next one we have coefficient of 4, the next one we have coefficient of 6, 4, and 1. And that's why you can see that this is 1, 4, 6, 4, and 1. So that's the way I keep about this coefficient. And not just that alone, when you're expanding, you have two terms in the brackets, x and minus 1. Don't forget to carry this negative together with the constants that you are dealing with. Now, as the power of one of the terms is increasing, the power of the other one will be decreasing. So it's okay if you want to use x as the increasing power. You want minus 1's power to be decreasing, it's fine. You can also do it the other way around to arrive at the same answers. But in my own case, x is decreasing. The power of x is actually decreasing. So after you can see that the first one is x to the power 4, the next one is x to the power 3. Of course, the coefficients will be able to deduce using Pascal triangle and so on and so forth. So let's just go ahead. If you are still confused, you can leave a comment in the comment section and I'll attend to you. So we can now collect like things from here. We have x to the power 4 minus x to the power 4. So this will be equals to 4. Let me erase this. Negative multiplied by positive. This minus multiplied by this positive. That will give us negative. So minus 4x cubed. Then we have negative 1. This negative 1 will give us positive 1. So this one will give us plus 6x squared. Negative 1 raised to power 3 give us negative 1. So we have negative 4x. Then negative 1 raised to power 4 give us 1. So we have. Now, that being said, x raised to power 4 minus x raised to power 4 will cancel out. So this will give us 0 equals to minus 4x cubed plus 6x plus x plus 1. Then we can decide to take the whole term on the right hand side to the left hand side so that we have 4x cubed minus 6x squared plus 4. So I beg your pardon, this is meant to be negative 4. Negative 4. We have negative 4. So when you take it to the other side, it becomes positive and negative equals to 0. So the next thing we do now is, in order for us to solve this, we need to factorize this particular polynomial of order 3. And so now you can now understand why I said this is not an equation of order 4. You can see that after simplifying this particular expression, the equation that we're given, you can now see that this is of order 3. So which means that you are only interested in 3 solutions of x and not 4. At first sight, you might think it's of order 4, so you might be looking for 4 solutions. But now you can see that we are only going to have 3 solutions. Now the other problem now is this: when you have a polynomial of order 3 and above, let's say from order 3, order 4, order 5, and so on, and you are to get the solution of the variable. One problem you might run into is that you might have to guess at least one of the solutions, especially when you are dealing with order 3. Order 3 means raised power of 3. So if you're able to guess, there's a way you guess one of the solutions right. Because if x is equals to 1, for instance, is a solution of this particular polynomial, it implies that when you substitute 1 in this equation, you must get 0. And if x is also minus 1, if x is equals minus 1 is also a solution, by the time you put minus 1, anywhere you see x, you must arrive at 0. So that's one way you can guess solution of a quadratic expression. But you run into problem if none of the solution of that quadratic expression is a whole number. So if it is decimal, you might find it difficult guessing a decimal number. Now let me just show you this in this case. The last time we said something about initial equations. If the power is the same, that means the base must be equal. Remember I said, and it's also one of the initial equations, initial laws. So you need to recall that if you have a raised to power of x, then equals to b raised to power of x. If the power of left hand side and right hand side they are the same, that means the base must also be equal. But the problem here now is, like I showed you earlier, we can't say that x is practically not correct for us to say that x equals x minus 1, because this will not actually give us any solution. But you also need to know that because we are dealing with even function, there's something that is very valid. When we say square root of, generally you say it is, but in advanced mathematics, we don't say square root of 4 is 2. Square root of 4 is actually absolute value of 2 because it can either be negative 2 or positive 2. Minus 2 times minus 2 will still give you 4. Plus 2 times plus 2 will also give you 4. So generally, it is not just 2 alone. It is both negative and positive value of 2 that will give you the value on the left hand side. And also, if you are dealing with even function, then that means that your negative and positive value are valid because if you have minus 1 power of 4, it will give you 1 eventually. 1 is power of 4 will also give you 1 eventually. So whatever value you are using for your variable, so long the power is even, it does not really matter whether it is negative or positive. You still arrive at the same answer. So that being said, it means that instead of you just saying x equals to x minus 1, you can now say absolute value of x is the same thing as absolute value of x minus 1. So this is what will actually aid us to solve for one of the solution of this particular polynomial. Now from here, it means minus x equals to x minus 1 or minus x equals to, because absolute value is talking about combination of both the negative value and the positive value. It's just that we don't want to write it twice. So once you just put absolute value, it takes care of the two values we are talking about, both positive and negative. So either it is minus x equals to x minus 1 or minus x equals to minus x minus 1, or we can also have x equals to x minus 1 or x equals to minus x minus 1. Then we can solve this equation to arrive at one of the solutions. Of course, earlier on we've been able to use that this particular equation does not have a solution because x minus x will give you 0, so there's no way you can solve that. So this is out already. So if you take any of the other solutions, we have minus x equals to x minus 1 or minus x equals to minus x minus 1. So let's solve it of this on the two. So we have minus x equals to minus 1 or minus x equals to minus x plus 1. Of course, if you look at this, you know that this also does not have a solution, so we don't need this. We have minus 2x minus 1 minus x plus x equals to 1. So this is out. So of course, you can see that this does not have a solution. But from here, we say x equals to 1. So now we have one of the solutions. X equals 1 over 2 is actually a solution of that polynomial. And recall that the polynomial we're trying to write is 4x cubed minus 6x squared plus 4x minus 1 equals to 0. This polynomial we're trying to factorize. Now we have one of the solutions that is x equals 1 over 2, which means that if you substitute 1 over 2 in this expression, it will actually yield 0. But that's not our interest. So what you need to do now is to get the other solution is if x equals to 1 over 2, we can simply bring 1 over 2 to the other side, so it becomes x minus 1 over 2 equal 0. So this is one of the solutions and one of the factors of this polynomial. So the next thing we do now is we need to perform a long division on this polynomial. So we have this using the factor that we've just reduced. Let me do it on the right. So we need to perform a long division on that. So we have this 4x cubed minus 6x squared plus 4x minus 1. So we have to divide this with x minus 1 over 2. So the first thing, x in 4x cubed will give us 4x squared. We have 4x squared multiplied by x, that will give us 4x cubed. Then this is positive, so positive multiplied by negative because negative, we have minus 1 over 2 multiplied by 4x squared will give us what? 2x squared. 2x squared. So then we can now subtract this. 4x cubed minus 4x cubed will give us 0. Minus x squared minus 2x squared, that will give us minus 4. Then we just bring down this positive 4. So we have plus 4x. X in minus 4x squared will give us minus 4x. So by the time we multiply this out, minus 4x multiplied by x will give us minus 4x squared. So we have minus 5x squared Minus multiplied by minus will give us plus. Will give us plus. 4x multiplied by half will give us 2x. So then we'll subtract again. Minus 4x squared minus 4x squared equals 0. Then plus 4x minus plus 2x will give us plus 2x. So we can now bring down this negative 1 to that minus 1. X into x will give us plus 2. Plus 2. Plus 2 multiplied by x will give us plus 2x. Plus 2x. Minus 1 over 2 times 2, that will give us minus. So then we can also subtract this. So 2x minus 2x will be 0. Minus 1 minus minus 1 will also give us 0. And recall that each time we are doing a long division, when it has to do with polynomial, and you arrive at 0, meaning that you don't have any remainder, that means your divisor is actually a factor of that polynomial. So we can conclude that this x minus 1 over 2 is one of the factors of the polynomial. And this other one will also give us the other two solutions that we're looking for. So this will actually result in something like this. So if 4x cubed minus 6x squared plus 4x, please pay attention to this. 4x cubed minus 6x squared plus 4x minus 1 equals to 0. And based on this long division, we've been able to deduce that 4x cubed minus 6x plus 4x minus is the same thing as x 1 over 2 multiplied by 4x squared. That's actually the quotient that we got after dividing 4x plus 2. I'm going to break this down. Initially, we need to factorize this, and we know that 4x cubed minus 6x squared plus 4x minus 1 is 0. Now, based on our long division that we just did, we can also confirm that 4x cubed minus 6x squared plus 4x minus 1 is the same thing as x minus 1 over 2 multiplied by 4x squared minus 4x plus 2. So if 4x cubed minus 6x squared plus 4x minus 1 is 0, so that means we can replace the whole of this we can replace it, so that you can see it, we can replace it with this 0. That's what it means. So we can now say that x minus 1 over 2 divided by 4x squared minus 4x plus 2 will be equals to 0. I hope you get that. And finally, for us to get the solution we are looking for, finally, we need to, don't forget we have x minus 1 over 2 multiplied by 4x squared minus 4x equals to 0. Now, if this one is like my working sheet, if we have a equals to 0, mathematically speaking, for this, the product of two non-zero numbers, a is not 0, b is non-zero, or let me say numbers now. For two functions, for their product to be 0, that means that at least one of them must be 0. So if a multiplied by b will give us 0, it implies that either a equals to 0, b must be equal to 0, in order for you to be able to confirm and ascertain that their product will be 0. So at least one of them must be 0. So in the same way, we can now come here and say it implies that x minus 1 over 2 equals to 0, or 4x squared minus 4x plus 2 will be equals to 0. Of course, we solved it before, so we can say that x equals to 1 or x squared minus 4. So all we need to do now is, this is not a quadratic expression, so we can use any of our preferred method to simplify this. But I think in this case, the easiest method or fastest method for me to use will be using quadratic formula. So we have x equals to b plus or minus square b squared plus ac divided by 2. In this case, a equals to 4, coefficient of x squared, then b equals to my coefficient of x, then c equals to 2, which is our constant. So substitute all these three values in the quadratic formula. Hence, we have x equals to, our b is minus, so we have minus plus or minus square root of minus 4 squared minus 4 multiplied by our a is 4 and our c is 2. Divide by 2a. Divide by 2a. So the next thing we do now is we simplify further. So we have x will equal to minus multiplied by minus will give us plus. That will become 4. Whether you include the positive or not, does not really matter. Plus or minus square root minus 4 raised to power 2. Minus multiplied by minus will give us plus. 4 multiplied by 4 will give us 16. Have 16. So when you multiply 4 by 2, multiply this 4 by 2, that will give us 8. Then 8 multiplied by 4 will give us 32. So then we can have minus 32. And divide by our a. Okay, I think I didn't include the value of a. Our a is 4, so we can say this is 2 multiplied by 4. 2 multiplied by 4. And that will give us 8. Then x will be equal to 4 plus minus 16 minus 32 plus minus 16. So from here we say x equals to 4 plus or minus square root. We can split this 16 multiplied by minus 1. And mathematically speaking, you can also unravel this. This is 4 plus or minus square root of multiplied by square root of minus 1. By 8. And in mathematics, when you see square root of negative 1, we say it's a complex number, so we use I to denote it. Then x will give us 4 plus or minus. Square root of 16 is 4. And square root of negative 1 is seen to be complex number, so we call it I. Which equals to 8. We can factorize 4. Then we have 4 times bracket 1 plus or minus I divided by 8. 4 here 1 is 2. So we have x equals to 1 plus I over 2, or 1 minus I over 2. Therefore, the true solution to the original equation that we were given is this: x or 1 over 2 or 1 minus I over 2. And that's answer. You can see that we only have 3 solutions and not 4. So I believe this tutorial have actually been helpful and insightful, and you can see that I dished it out with prowess, and it's very easy to comprehend for everyone. So if you have actually gained something tangible from this tutorial, please give back to this channel by hitting the like button so that YouTube algorithm can recommend this kind of content to others. And also don't forget to hit the notification bell so that you will not miss out on any insightful information that will come your way anytime from now, because practically I drop content every day so that you get updated and keep your knowledge database up to date. Please do like, do hit that notification bell, and also don't forget to subscribe to this channel, and I'm grateful to you for doing so. Thank you very much, and I'll see you.